Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. And what you're about to see is a pre-recorded training session we did over in the United States. But be assured that a lot of the material that we cover is really applicable to any automotive application. So just be aware that yes, it is a lot of North American vehicles, but they will apply a lot of the same principles apply over in the UK as well. Now, if you do have any questions, if you're watching this during the premiere, you can just leave it in the chat. We'll be monitoring live chat. If you're watching this after the premiere, then just feel free to leave a comment underneath the video and we'll get to those as we can as well. So my name is Jason Gabrenas. I'm one of Snap-on's diagnostic technical trainers. I've been in the training department since 2013, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep at Snap-on, so I had 30 different franchisees I worked with, as well as the shops that they serviced, in order to help everyone get the most out of their diagnostic needs. Then before I did that, it was 8 years at Subaru. So I worked in a dealership, and over time, I guess, just became the default diag guy in the shop. So I always ended up having the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that would come into my bed. Then before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. So our topic today is TPMS operation and testing. Now, we have discussed TPMS in the past, but that's been a couple years ago, and there have been some changes and advancements in tire pressure monitoring systems that we're going to talk about tonight. So let's first start at the beginning, though. We'll start it with a little bit of history lesson, right? We always like to do that. So in 1986, TPMS was on the first production vehicle with TPMS, widespread production vehicle. I'm sure there were some others that may have had that before, but the most widespread one was a Porsche 959, 1986. The system used two sensors mounted 180 degrees apart in special holes in the valley of the wheel. They looked like a stack of poker chips, so all the electronics and so on were set inside there, and it looked like a small stack of chips. Transmitted is a 433 megahertz frequency. That'll be important when we talk later. And you could get codes and data from the scan tool. There really weren't any other specialized tools to work with that. It was also used for 928 models from 1990 to 1994. Then in 1997, so that's a big 11-year span, the first U.S. production vehicle with tire pressure monitoring system was the 1997 Corvette C5. And it was Schrader's first OE TPMS. Schrader makes a lot of TPMS sensors and other components, hence the name Schrader valve, right? Comes from them. Now, the interesting thing with this is you see this magnet right here. That is how you would activate it. So you'd actually slide it over this valve here, and when it gets close to the wheel, it'll pull a magnetic switch, and that's what actually activates the tire pressure monitoring sensor for programming purposes, things like that. Back then, vehicle manufacturers really had no standard tire pressure monitoring systems. Used either a simple dash light, or on higher end cars would have each tire shown. And nowadays, it's kind of standardized, I guess, but there's still many different ways to work on them, relearn them, and so on. But as far as the sensor types, there's only really a couple different sensors. And that brings us to 2000 with the TREAD Act and the National Recall System. So in the United States, a large U.S. vehicle manufacturer called a bunch of vehicles. If you remember back then, or you kind of know the story here, you know who that was. A bunch of rollovers and a bunch of deaths, unfortunately. So 279 accident deaths over, I don't know what the span of time was. But they recalled a total of 14.4 million tires as well. Now, this TREAD Act says the law intends to increase consumer safety by mandating TPMS on all vehicles under 10,000 pounds, starting in 2004, and it was assigned to the National Highway Traffic Safety Administration to administer this. They must notify the driver when the tire is below 25% by a dashboard warning light within 20 minutes of that happening. So a little bit later, they ended up implementing this in Europe as well, and up to a stricter standard, of course, like they usually do. But this act was signed November 1st of 2000. And nowadays, not sure when it actually kind of came online. We don't have that as part of this history, but big rigs and large trucks now have this on them as well. So And it's not just cars and trucks either. We got motorcycles, we got trailers. We're going to talk more about that in a little bit. So the light requirement that came out in this act is you need to have a solid light if tire pressure is detected under or over 25% of the OE door placard value. And if we change tires, we change what we need to set our pressures to. We need to actually go in with the scan tool and adjust that. If it's flashing 60 seconds in a solid light, that means at least one sensor isn't communicating with the vehicle. Could be a dead battery in the sensor, could be a damaged sensor, could be an incorrect relearn. When you start a relearn, often it wipes out what was already in the module. So if you can't relearn it properly, it could cause a problem there. Or an additional tire pressure monitor component failure, such as the module, the wheel initiator, the ECU, and you would need a scan tool to go in and scan that. Now, many cars, you will see that PSI light. So if I have a pressure issue, this will come on, or it'll flash if we have one of those problems. On some vehicles, it will also have this alternative logo here, or icon, I guess you could say, that dash light for any DTCs. So if you have a pressure warning, you get this. If you have any codes, you get this. Not all vehicles have that, but if you see that, that's really what that means. Now, how's the system laid out? How's it work? So each tire, each wheel has a sensor in it at the tire pressure valve stem, right? So we left front, right rear, left rear, and also the spare, depending on the vehicle. And also it would work on dually vehicles too. So you have inner and outer rear tires. So it would have a procedure for that. Each of these has a unique ID, transmitting ID number. So the computer needs to know which one of those is installed on the vehicle and what corner it's installed on. So this is very important if you do any tire work and you put the tires in a different corner of the car, like you do a rotation or something like that, the computer needs to know, because otherwise it may mislead the driver. So if I did a rotation and I did not relearn these to the vehicle, then the vehicle may say, oh, well, now that tire is 24 pounds and it's the right front when really it's the left rear. So it can confuse the driver, confuse the owner. If the system doesn't know what's where, then that could be a problem. So we need to relearn them. We can use we're going to walk through a couple different ways to relearn them, and it's by no means an extensive list tonight, but you often do need a tool specialized for tire pressure monitoring. In this case, we have a TPMS 5 shown here, and you want to make sure it's set to the door placard. So 35 PSI in this case, it looks like, and then it just transmits. So a closer look at the transmitter. It's going to have different protocols on it. The software is called a protocol. It can measure pressure, which is the most common. Temperature on some of the newer ones. ID number would be common. Transmission time would be maybe on a newer one. Frequency, the transmitting frequency of the 315 or 433 megahertz. Like I said, that's kind of important. Or even newer ones, 2.4 gigahertz Bluetooth low energy. Also can give you a battery status, whether it's low or normal. It's got a little RF antenna in there. Doesn't actually look like an antenna. It's actually built as part of the piece. It has a lithium-ion battery in there that's non-replaceable, 7 to 10 year life. Now, this is one thing that a lot of people seem to have forgotten at the beginning anyways. Maybe now it's a little more common, but back in the beginning of tire pressure monitoring, they didn't really take into consideration that battery has a life. So 7 to 10 years on average. As far as I know, let's put it this way, as far as I know, my tire pressure sensors have never been changed in my car. My car's 13 years old, and as far as I know, they're still original and the battery still reads okay. I actually just read them this afternoon to get a screenshot. So maybe they've been replaced. I've never seen it as a line item on when I get my tires done. I've had the tires replaced a couple times, never seen it there. So not sure if they just threw it in, but as far as I know, they're still original. So they can last longer than 10 years. I guess so. 7 to 10 years average life. Could be longer, could be shorter. But that would throw a code, right? Because it wouldn't be able to transmit if the battery's dead. The most common types you're going to see out there are banded, clamp-in, and snap-in. Now, the banded are not very common anymore. They were kind of common kind of early. Most Fords would use them early on. They discontinued them around 2009, 2010. And that's where a band wraps around the entire wheel and it clamps it kind of in place in the center of the tire. The transmitter and the pressure sensor are built right in one unit. Now, I have seen some aftermarket ones where you can add aftermarket tire pressure monitoring to your vehicle, or maybe for a trailer or something like that. You can add them onto the trailer tires, so you can check your tire pressure, from the cab. So some of those are banned in, but not very common on just a regular factory vehicle now. Clamp in, less common now. Early on, I think they're a little more common. And there's your sensor. There's your little nut that clamps in, and then we got a little O-ring right there that seals it. And then most of them nowadays are going to be the snap-in type. So the snap-in is basically just takes the place of a regular valve stem, snaps in just like a regular valve stem, and then we have the electronics package on the back, which has a little torque screw that will screw into the valve. And I will tell you, up where I live and anywhere in the Rust Belt or anywhere in the north, so to say, of North America, where they put a bunch of salt on the roads and other chemicals on the roads in the winter to dissolve the snow, these things get corroded pretty quick, and then you can't take them off. So most of the time when you try to take them off, you end up breaking them. I've had to cut them with a die grinder just to get them off, to replace them with new ones. And we would usually, as long as the vehicle was compatible with it, I would usually replace them with the rubber one. That way we don't have this trouble in the future. Now, also, the caps can get stuck too because they're brass and they actually extend a little bit lower. The caps themselves are not brass, but the valve stem is brass, and they're actually a little bit lower, a little longer on the valve cap. So sometimes those can corrode, and then the caps will get stuck. But of course, you could clean that off and fix that. Most common on these, and even these plastic caps would break all the time too. So in 2007 to 2020, Schrader was the biggest supplier of rubber snap-in valves. There's the different types that they had. You can see where the air would go in, and then you can see where the sensor package actually bolts on there. 75 to 80% of the market was that rubber snap-in. The rest would be the clamp-in, most likely. It's two-piece, low cost, and easy to install. And then you also do need some special, or you want to use some special tooling. In this case, they're preset torque. So that's for the torque bit or the torque screw that goes into the right here, right into the valve stem. And then also for the Schrader valve, you need to make sure you don't over tighten it. And also there's a special tool for the nuts for the clamp in ones as well that are set to a special torque, because you don't want to over torque them because you break them. They're pretty fragile that way. As far as measurement is concerned, 94% of the US market uses direct measurement. So that's your majority of cars from when they started. 08 to 2012 Accords, Acuras, etc. Indirect is where they don't use a tire pressure sensor, actually. They use a wheel speed sensor in order to measure it. So some Audis, newer Hondas. I rented a Hyundai that had it. So they don't have the actual tire pressure sensor in there. They just have regular standard tire valves. And then they use the wheel speed deviation from wheel speed to detect whether or not that wheel is low or that tire is low. In 2009, VDO introduced a multi-application, what they call a ready sensor. So it offers 6 to 7 different part numbers available in both 315 and 433 megahertz applications, depending on what the manufacturer needs. And all the OE software is stacked on a single sensor chip. So I can duplicate OE sensors. I can just clone them if you want to think of it that way. We call it cloning. So you can just take the data off of one, put it on another one, and the car doesn't have any idea that anything changed. So we can see that there. You can actually go into the tool, go to replace. You can unlock the sensor. Some of the sensors need to be unlocked to do that, and it would allow you to do that. So that's pretty handy for a shop owner. You only have to carry like 7 different part numbers of a sensor, and then you can program them at will. They're basically a blank sensor. You just copy and paste the information off the old one to the new one. So I could see how that would be helpful. But there are over 20 brands of programmable sensors that we do cover in our tool. And that would be the TPMS 5, able to do relearns and such. There's really only 2 in the aftermarket that we know of that aren't covered in the tool. So one of them is the Autel one, because that is tied to the tool. You have to use Autel sensors with their tool, or the tool with the sensors, put it that way. And then Schrader actually has one. So Schrader has 2 types of valves. They have one that's universal, it can be used by anything. And then they have one that's tied to their actual tool that they have for tire pressure monitoring. So those are really the only 2 sensors on the aftermarket that we know of that we don't cover. And you can actually go in the tool and see what's the OE part number, what's the frequency. It's built into the tool, and then you can also pick any of the brands. And then there's high lines, low lines, steel wheels, alloy wheels, clamp-ins, snap-ins, etc. So you can sort through the list and find the year and the type and so on and so forth for the different softwares, and then you can just go in and clone them. So I can pull the software off the existing one, or pull the data that I need, not necessarily the software, but the data that I need off of it, like the ID number and stuff like that, and then program it into a new sensor, a blank sensor, and then it just works. Notice how the newer style clamp-in sensors also have a removable sensor. So that saves the problem of I probably never have to take this off again once I put it on. So that solves the problem of the corrosion, and I can just replace the actual sensor body itself and just leave that stem in there and don't have to bother cutting it off or anything. Now in the shops, technicians face no standard service relearns. And it's really, it was the same at the beginning as it is now. It's every manufacturer for themselves. There really is no right or wrong way to do it. And there is no standardized way to do it. So GM in this case says 33 procedures. It's actually a few more than that now. And they're usually stationary, where you do it in the bay. BMW has 15 different procedures, and it's an automatic where you drive it down the road. You set the tire pressures a certain way. Nissan actually has a couple different procedures now, but one of them that was the most common for the longest period of time, you can do it with the TPMS tool or without the TPMS tool, and it tells you how to do that, and we'll show that in a little bit. But here's just a little quick reference, just a sample of just GM vehicles, right? And there's totally different ways to do it after. So some different reset procedures out in the industry. So one good way to find the reset procedures, if you have a Snap-on tool, is going to be quick lookups. As long as you have Wi-Fi and current software on the tool, you can access the quick lookups. And we have an option for tire and wheel service. We also have oil specs and TSBs on the Zeus, but oil specs on all the other ones as well. But tire and wheel service. And this is an example of an 18 GMC Acadia. So that's procedure number 11. It's going to walk through the entire process. So you're going to press and hold the select button on the driver information control. And they'll say tire learning active. And then you're going to use a sensor activation tool like a TPMS 4 or TPMS 5 or something like that, and activate starting front left to the rear left. So you're going to go clockwise around. So left, right rear, left rear. And I have never seen a manufacturer do it a different way. Now, they may have different ways of putting it in a learn mode. They may have different ways of activating it, but they always start with the left front and end with the left rear, and they make a clockwise circle around the wheel. So I guess there's one thing that's standardized in the industry, I guess. But that's how it knows what wheel is on what corner. Here's another example for a 2018 BMW, and you actually do that inside from the My Vehicle and iDrive. And then reset tire pressure monitor, start the engine with do not drive off, reset the inflation pressure, and then drive away. And then it'll learn it after driving over 19 miles an hour for a short period, and it will tell you when it's done. And then for a 2018 Ram 1500, which is a pretty common vehicle, there is no actual reset procedure to do. You have to actually do it with the scan tool. So from here, we could go into functional resets, which brings us into the scan tool. In this case, it's an 18, so it is security link access. And then you go in and it says program the IDs. So I actually have to go in and type the number of that sensor. So let's say I picked the left front. This function should be used to write the left front tire sensor ID in the ECU. You hit continue, and it'll tell you what the current ID is. Make sure you have the 8-character sensor ID available. It can be found on the tire sensor label. It could also be found using the tire pressure monitoring tool. You can extract that from there. And then some vehicles will actually have that as data PIDs as well. So you can do that. Just make sure the tire's in the right spot, because the computer only knows where it's programmed to. You go in there, you hit edit, and that's going to walk you in here. You type in your sensor ID, hit OK. It's going to verify, and it's going to say it's successful when it's done. Here's another example on that Nissan I talked about, that Nissan procedure. We have one with a transmitter activation tool and one without. So if we go into functional reset, it'll bring us there. So TPMS registration with the J45295 tool or without. And that J tool is one of these. So something that can activate a sensor. So it's got the little antenna on there, and you can go in and activate the sensor. Without the tool, And with existing sensors, because if they have new sensors, you have to use the tool. But if you don't have the tool and you have existing sensors in the vehicle and you just need to relearn it, what you need to do is you need to set the tire pressure according to what they want. And every, different models have different pressures. So this isn't the only way to do that. So left front's 34, right front's 31, right rear 29, and left rear is 26. So that's going around clockwise again on the vehicle. And you set them to that, and then you drive the vehicle, and then it senses, okay, so I see 34 PSI in that tire, so that must be on the left front type of thing. So you probably want a pretty accurate gauge on that as well. Right, and then it says continue to start the test, and then we drive the vehicle 5 to 15 minutes until it says test completed. So that's using the scan tool in conjunction with, actually in that case, it's using the scan tool without the TPMS tool. Other times you need to use the TPMS tool in conjunction with the scanner. Here's another couple examples of things that we can do that are related to tire pressure monitoring. With a scan tool, many scan tools can do this. So tire type and pressure selection on the 2018 Acadia. So we choose what type of tire it is, and then we go in and then we can change the pressure. So edit for the front. You can go anywhere from 26 to 95 PSI. And just choose the one you want. So let's say we wanted 44. Go in there, you hit continue, and then it has you do the rear as well. Hit continue again, and it'll program those values into the TPMS. What if I have a dead sensor that's not transmitting? Sometimes I still can't extract it using a TPMS tool. Otherwise, I can go in PID data. Sometimes it'll be there as well. So if my sensor is not communicating, it's dead or something like that, sometimes I can get the information off of it if it's got just enough juice. Other times I can go with PID data, but that's in the case where I may need to manually enter that sensor ID like on that RAM. Right, so I would take that number right there, that 8-digit number, and then punch it in there, and then that would be left front is. Motorcycles have TPMS now too, and that is capable on the TPMS 5. You can do that. So you just ID the vehicle. In this case, we got a 2020 GL 1800 Honda, and it has what are ID numbers for the front and rear. You can ping them with the tool as well. So there, a couple of Hondas, BMWs, Indians, Harley Davidson. Somebody had a question on the last class about Harley, and yeah, that's in the tool as well. That's not in the scan tool. It's in the tire pressure monitoring tool. So it's available. Also, dually trucks over 10,000 pounds. So like your 1 tons and over. They have 6 tires plus a spare, so you can do 7 actually. Left front, right rear, inner right rear, left rear, inner left rear. Is how you do that, and I'll just walk you through that. Also trailers, so you can look up trailer TPMS, GM, Ford, whatever. Also in here, you may have to go into the vehicle and go into like a trailer setup in the driver information center to set that up, but then it'll show you your trailer tire pressure as well, and that's on some vehicles, 2019 and 20 and newer. Some vehicles have it, and we can do that. And also the newest game in town is going to be 2.4 gigahertz Bluetooth. So it actually uses Bluetooth low energy, and Tesla is the one who uses that right now. I actually got one in front of me right here. So this is it says BLE, Bluetooth low energy. And this one's actually a clamp-in style too. So it's got the little screw. You probably can't really see it with the camera, but it's got a little screw there. It screws in, clamps on the rim there. And it's got a little screw in the back, and that's just like any other clamp-in, but the actual sensor itself is Bluetooth, not radio frequency. Right? So that's available. And that's also available in the tool. So as long as it's updated May 2023 or newer, it has that capability built into it. That was added then. So it'll tell you the frequency, in this case 2.4 gigahertz, and it'll tell you how strong the battery is in millivolts, and then what the ID numbers are as well. So that's the capability that's out there as well. So if you're doing Tesla wheels and tires, I hear the tires don't last that long on them, so because they're heavy. So might be something that's necessary, and it's available with an update. All right, let's go live on the scan tool, since I can't hook up my TPMS 5 to the internet to see, but we can go live on the scan tool. I'm going to pull up a few vehicles we have here. The first one's going to be a Chevy Equinox 2016. It's going to be awfully similar to that GMC Acadia. Similar, not the same, but similar. So you can go in here. A couple different ways we can go in there. So first off, common selections is usually going to have the tire pressure monitor right there because that's one of the more common things to do. You can go codes and data. Let's see what we have in data. Sensor data. It's going to tell you your signal qualities on the sensors. And then if I go to the next data group, which would be the system data, it's going to give me like my pressure status, my sensor IDs. So that's where you can get those sensor IDs, sensor modes, location learned, yes or no, that sort of thing. So you can actually go through all that and see that PID data in the case that where you needed to gather that information. We also have functional tests, tire type and pressure selection. So this is where I would go in and choose my load range first, say load range C, and then go in there and then change up to, say 80 PSI for some reason. I wanted to do 80 PSI as my minimum. They continue, and then it'll load the rear. Say the same thing, 80 PSI, continue. And we'll load it in, load it in. There we go, done. Easy enough. It's just flipping a switch inside the module, basically, what it's doing. Now, also, alternatively, if I have a tool with the service resets and relearns active, I can go in here and I'm going to scroll down till I get to TPMS, tire pressure monitoring system, replace tire pressure sensor. And it's going to pull up some data. It's going to pull up any TSBs if applicable. And then I can go in here and it's going to give me all of my options. I don't have to go into the different menus to find it. TPM learn mode, sensor signal reset, and tire type and pressure selection all on one screen. So I can access it that way. And then the third way to do it, like I said, we got quick lookups on the front menu. Tire and wheel service. There's an Equinox. And then there it is, procedure 33. It's going to walk you through how to do that. Each sensor has a unique identification code. The identification code needs to be matched to the new tire and wheel position after rotating the vehicle's tires or replacing one or more of the TPMS sensors. Okay, so that's how we do that. Next one, Grand Caravan. This is going to be very similar to that Dodge Ram. They've been doing it this way for a while, apparently, because this is a 2011. And I can go down to, oh, it's actually on the top. Never mind. Remember I said that's usually on the top. Tire pressure monitor. And then we have codes and data, miscellaneous functions, which would be reset ECU and ECU information. And then we have system tests. So that's where you go in, program the ID. Need a 7-character sensor ID. Make sure it's readily available. Enter only the last 7 characters. If it has more than that, there's your current ID number. Go in there, say I wanted to do 1, 2, 3, 4, 5, 6, 7. You do that. Okay. Okay. Verify. Okay. Programs it in, and you're done. And of course, this is a simulator, so it's just going to go back to where it started. But if it was successful on a real live car, you would see whatever number you entered. Then there's a rolls test there. Verifies the TPM sensors are transmitting and being received by the TPM module. It should be run when a new tire sensors are programmed. Vehicle speed must be about 20 miles an hour for at least 30 seconds after the procedure starts in order to force the sensor transmission. And then begin driving. Just drive down the road, and then when it's done, it will exit. It will verify. I can't do that right now because I'm not driving a vehicle. Okay, that's that. Do a Mercedes CLA class. So this one's a little different as well. They're all a little bit of differences you're noticing, right? So we'll go to tire pressure monitor. And we'll just pick the first one. There's a lot of different variants that could be. It's going to decide which one it is based on the car. Special functions, right identification IDs of tire pressure sensors. So are the wheel electronic ID numbers known? So those are the code numbers again. They're printed on the respective wheel speed sensors. You can probably grab them with the tire pressure tool too. Wheel electronic ID numbers are printed on the respective wheel sensors. And then you would go in, you would edit it, dial it in, hit program again, and then it would finish. All right, a little different on that one. And then the last one is going to be my F350. It's where we talked about the 6 or 7 tires, depending on if I do the spare. F-series. Tire pressure monitor. We have tire pressure monitor in there. functional tests, special functions. And then we have a training mode with the scanner and the training mode without a scanner. So with the scanner, it's going to erase any location that's already in there. So make sure you want to erase it before you go. Hit continue. There, it erased it. That's going to tell you what your pressure is, your ID numbers are. And of course, right now we're not going to have any. And then it'll sound the horn. Then you need to use a sensor activation tool like a TPMS 4 or TPMS 5 or something of the like. Go around left front, right front, right rear, left rear. Like I said, always goes around. Outer and inner, because you notice we have the outer and inner. Right rear outer, left rear outer. And then also training mode without scanner. So it's going to tell you the manual way to do it. Right, how to walk through that. So many manufacturers have many different ways of doing this. Always best bet is to read up your service information. We try very hard to make sure we put the information in the scan tool as well, in the scanner part, not just the quick lookups part, just so you have that information readily available when you're actually doing the tests. So that is tire pressure monitors. A few new enhancements there, a few new advancements there in tire pressure monitors. So hope you learned a little bit or a lot, whichever. And with that, that is our time here today. So make sure you tune in for new diagnostic content every week. We will be premiering a new video every Wednesday at 7 p.m. UK time. So make sure you check it out on the YouTube channel. If you're watching, well, of course, you would be watching this on YouTube, but make sure you subscribe, thumbs up, ring the little notification bell so you know anytime we post new content. And it's youtube.com/SnapOnDiagnosticsUK. With that, time for questions. If you have any questions, just feel free, once again, if you're watching this on a premiere, just leave it in the live chat and we'll answer those. Otherwise, leave a comment under the video and we will get to those as we monitor those comments as well. So I'd like to thank you for taking a little bit of time out of your day to learning a little bit more about how you might be able to be more efficient at diagnosing vehicles using some of the information that we've given you today. Hopefully we'll see you next week. Hopefully you can watch and see you on any of our other videos. Have a good week, have a good night, and take care.